I was saying at the end of last time in class about shapes and that we use antibodies to recognize shapes and to determine, oh, that shape is me, that one is okay, versus that shape I've never seen before, so that must be a danger. All of that applies to the acquired immune system. And this is a picture of a particular white blood cell that is one of the major operators in the acquired immune system. We also have seen this picture before describing what are all the things that a pathogen or a foreign particle has to overcome if it really is going to cause us problems. It's got to get past barriers, which are basically skin and mucous membranes. It has to survive these chemicals that we make on surfaces and body openings. Also, flushing mechanisms. I would write that in up there. And then these processes. So we have natural killer cells. We have inflammation with all of its steps. We have phagocytosis, where we have immune cells eating foreign invaders, and then we have fever, which is protective. The barriers and flushing, that's the first line of defense. If you get past that as a pathogen, the chemicals and the processes are second line of defense. And if you get past that, that's where your acquired immune system comes into play. So third line of defense, which includes these parts, that's acquired immune system. There are a lot of pathogens that don't ever make it to this point, so we don't truly mount immunity against them. So if they get far enough, we will start the process of making this kind of immunity. I'll come back to what's cellular and what's humoral in a minute. I haven't said enough yet to make that make sense. We also talked about last time, what is the acquired immune system generally like? Did we? I think it was just stuff that I wrote on the board. It wasn't in a slide. It's the same as what this is saying, but these are in different wording. We don't already have acquired immunity. If we did, we would say it's innate. It's not innate. We have to be exposed to the pathogen if we're going to develop this. So acquired immunity has to be developed. You have to make it. You have to do a process to make that kind of immunity. It takes a while to accomplish that. So next to slow, or out here to the side, write that slow means it maybe takes 2 or 3 weeks at least to develop this. Like, if you go today to get your flu shot down at the student center, you don't walk out of there immune you don't walk out of there immune. About 3 weeks from now, you'll have some level of decent immunity. 6 weeks from now, it will be a lot better. It takes time to develop. Once you do develop it, your cells, your immune cells, are going to remember the shapes or the antigens. So if you make immunity against, if you make immunity against chickenpox, you've got these cells that just hang around in your body waiting to see chickenpox again. And when they do, they're like, oh, I remember you.
Do they ever disappear?
They eventually will die out. So very, very elderly people may have lost their immunity to certain diseases they were immunized for. Or when you get old enough, just everything is kind of breaking down. And you might need to get some more shots at that point. But really, up until you're about 50. until you're about 50, your childhood shots are pretty good.
That's quite a long.
Mm-hmm.
That's a long time. Like, if you really think so.
It is a very long time. Like, think about how long a red blood cell lasts. It's 2 or 3 weeks. But we have some white blood cells that they hang around in low numbers and they remember what they saw. And then if they see it again, they're like, divide, 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 and then they enact immunity. This is the third line of defense. It's not, we don't use it right from the start. We use it if we need to use it. And the major players are antibodies. Antibodies are part of the third line of defense. They're part of acquired immunity. Antibodies that you make, not makes, antibodies that you make, and B and T lymphocytes are involved with this. I want to draw, I don't think I have a separate slide about B and T lymphocytes. I want to say a few things about them. B lymphocytes mature or are educated in a way to know what's us, what's not us in the bone marrow. B lymphocytes get their shape training, let's say, shape training in the bone marrow. T lymphocytes get their shape training in the thymus. So remember, thymus, it's about right here. It shrinks as you grow up. Your T lymphocytes are supposed to be getting their training, what's you versus not you, when you're a child. And then they're done, and then the education center, thymus, can kind of shut down. Like your old elementary school, that there's no kids to go to it anymore, so it's shut down. That's happening around here. B lymphocytes produce antibodies. B lymphocytes, or B cells actually make antibodies, and we'll look in a minute how do antibodies even help you. B cells make them. T cells, or T lymphocytes, help B cells generally. If you take microbiology and immunology, like I spend a whole day on these two and what they specifically do, but for this class, I've got to move on from here. I'm going to talk now about antibodies. So antibodies, if we have antibodies against a certain substance, it's because they're made by the acquired immune system. The antibodies bind to specific shapes called antigens that are on the surface of pathogens. So it's not so much, if this is a bacterial cell, it's not really that the bacterial cell is the antigen, but there's parts of it on the surface, like I compared to Jake's shoes. They're like, oh yeah, those are Jake's shoes. By binding to the shoes, I'm also, in a way, attacking Jake, but it's the shoes that I see. Not all of Jake. That seems weird, but that's how antibodies work. So they're going to bind onto the specific shapes that are non-self. Right above the word shapes, they're non-self shapes, if everything is working the way it should be. Here's how antibodies actually help. Pretend like antibodies are police dogs. Where do police dogs bite people? Like on the leg, right? They're trained to bite people on the leg. I don't know.
That's a forearm.
Their arm? Yeah. They don't care who the person is. It's like, there's an arm, I'm gonna bite it. Like, there's an antigen, I'm gonna bind it. Okay, so if the antigen is all over the surface of this bacteria, you can have a lot of antibodies binding it. or would be sad, but a lot of dogs like biting the person. And then if you are an immune cell, to do some erasing here. If you are an immune cell, like a macrophage, and you see like a large accumulation of antibodies binding to something, that's an indication like, oh, something's going on over there, I need to go over there. There's a ruckus. There's a lot of antibodies binding. So see how this is this? These are tagged with antibodies, or they're like bound to dogs. And then the policeman that eats you can come over and like, oh, I see something going on, I'm going to go eat that. So antibodies are a signal for a larger cell to come over and deal with this situation. Some antibodies could also act to bind onto a working part of the pathogen. So that virus needs that little part to enter human cells. Needs that part to enter human cells. Like, if I had some keys in my hand and because I stole them, and then it's like, I'm going to use these to go break into Chris Slaughter's office and steal his cool stuff. Well, if there's a dog biting my arm, I can't do that. Like, I can't use my tool to do my work if there's a dog hanging on my arm. So that's neutralization. Antibodies can bind onto a functional region and block it up so it's not useful. Antibodies can do that. I like this one a lot. Antibodies have two binding regions. They tend to have this Y shape. I'm not drawing that quite correct, but it's got two binding sites. Just like we have two arms. Whatever this side binds, this side will bind the same kind of thing. This would be like, what if you had two-headed dogs and each head could bite its own arm? Well, then you could end up with a situation where it's like there's a bunch of dogs and there's a bunch of criminals and they're just all bound up together in a giant scrum, pig pile. That's what we called it when I was a kid. If this is noticeable to a macrophage, this is like, whoa, call all available macrophages to this situation. This is a mess. So they signal macrophages to come over and eat this. This one, I'm not going to go there in this class. This one, there are also ways that antibodies, by doing this kind of binding, they can cause holes to be made in a bacterium. This is called complement system. Complement system activation. These particular things do not really come up in your career unless you're going to be in nursing. So I'm not giving them the technical names, but these are ways that antibodies can help you fight off invaders. And they're all very cool. So if you have antibodies, if you have shape binders for these shapes, those are some ways that they can help. Your acquired immune system helps you make antibodies against pathogens that the inside of your body has seen or experienced. This is a more realistic 3D picture of an antibody. It's still Y-shaped. It's got two binding sites. Whatever this side binds, this one binds that same thing. Yeah.
Were we supposed to fill in the boxes?
No.
No.
Those have specific names, but for this class, the names aren't important. We go over the specific names in nursing micro, and they're important.
So she's like how they work.
That's so that you can understand, like, who cares whether we have antibodies? Because otherwise, it's like, well, if I just talk about this and I don't show that other thing, like antibodies are very dull, if you don't know this. So, I have to put that. I don't like for things to be dull or boring. So, like imagine I just had this slide. Antibodies lead to destruction. This is how they lead to destruction. So yeah, you should generally know if antibodies are attached onto some shape, some antigen, they're going to lead to destruction. This is generally how. And also remember, if people have autoimmune diseases, they are making antibodies against their own antigens, and their own antigens will be destroyed. Like, there's an autoimmune disease called myasthenia gravis, and it destroys nerves, specifically in the throat. So the people that have these spells, they can't talk well and they can't swallow well, and it's very disturbing for them. I don't know why, just the throat nerves. It is known, I just don't know why. This slide, I also want to spend some time going through this as well. So here we have some graph. It's actually one graph. And whenever you see a new graph, you ought to look at the axes first. This is how I approach this. So we're looking at days. So this is days. Days after exposure to an antigen. You can assume that this is a foreign, non-self antigen. Let's write that on. I'm going to write all over this. Okay. So this is a non-self foreign antigen. This arrow here, that represents, the first time I ever came in contact with that foreign particle, that was my first exposure. And this is showing plasma antibody concentration. Oh yeah, antibodies float around in your plasma. That's kind of important. So they're going everywhere your plasma goes, including squeezing out through capillary cracks, if necessary. They're going everywhere your plasma goes. So plasma antibody concentration. These are antibodies that your acquired immune system made, or let's say makes. You don't have a lot of antibody against that thing until you experience it, and then you start making it. So you experience it, you start making some antibody, and the levels will peak, 3 weeks. You get some reasonable level of antibody after 3 weeks. So the more of this you have, the more of this that you can do, and the better you can fight off whatever thing that that antigen represents. So you need a decent number of antibodies to be considered immune. And then after that, the antibody numbers start declining again. Also, after this, say when you get to about this point, you create something called memory cells. Memory T and B cells. And those combined kind of know that antigen and could recognize it. They're the ones that hang around for years, and they're like obsessed. It's like Moby Dick. What's that captain? He's like obsessed with Moby Dick.
Ahab.
Yes, thank you. That's pretty much, I should know that. Captain Ahab. He's so obsessed with Moby Dick, and Like, that's the only thing he cares about for years. Just sailing around looking for it. There could be another whale that's kind of like that. Doesn't matter. Moby Dick or nothing. This antigen or nothing. So these memory cells last. When you see this little break, there's a little break in the time. That could be 2 weeks later. That could be 5 years later. It could be 40 years later. These cells, these memory cells, hang around. They're still looking for that antigen. So the second time, any subsequent time, second, third, etc., time that you see that antigen, these memory cells are like, aha, aha, and they're going to quickly make lots of antibodies. So second, third, subsequent times, you get lots of antibodies fast. Lots of antibodies fast. And this time around, it's in time to not get sick. Like this first time, if this antigen is something that is attached to a pathogen that makes you sick, you're going to get sick. You're going to get sick. Because your antibodies can't catch up with how fast this pathogen is multiplying in you. This time, you get really quick antibody production, and that's enough to fight off the pathogen using these cool warfare techniques. You're likely not going to get sick. Or you might feel like a little bit sick, but then you get over it, and you go on with your life. How's this seem? Hurts me to have to go through this so fast. Hurts. Your immune system is amazing. So amazing. Okay, the next slide seems like drastically different, but this slide is directly related to this slide. And these methods, these 4 methods that we're going to talk about next, have to do with how did you get the antibodies that you have right now. So it says 4 ways to acquire immunity. Instead of immunity, write decent levels of specific antibodies. How did you get the decent levels of specific antibodies that you have right now? And we classify these methods as being natural or artificial, or active or passive. So I'm going to write some definitions of natural, artificial, active, passive over here on the side. And your book gives you definitions too. Is this from your book? Even? I don't know, because you had TBA, so you don't know. You still have to know it. You still have to know these. Okay, if we say that something is active immunity, that means that you made the antibodies when you were exposed to the antigen. You made those antibodies, your very own self, by some method. If we say that something is passive immunity, someone else made the antibodies. Someone else made those antibodies, and in a way you can think of it, they made it for you, kind of. So that's active versus passive. The other 2 definitions are natural versus artificial. And my definitions for these are very silly compared to the book. Natural Sometimes I say desert island. It can happen on a desert island or in an uncontacted tribe or people who have no access to what we think of as medical care. Like, people without doctors could accomplish this. That's natural. If it's artificial, that's some kind of method that requires modern medical intervention. So these things are a mix and matchable. You can have natural passive, you can have natural active, you can have artificial active and artificial passive. And this screen picture is now showing all those combinations, and they've got a helpful picture of a person that's happening in. So let's start with natural. Natural active. So this did not require modern medical treatment. I wish that she wasn't putting a thermometer in his mouth, because that's misleading. This boy has gotten sick with an infectious disease, and he lives. And because he made it, he made antibodies because he survived. He got the disease, he encountered the antigen, got sick, lived, made memory cells and antibodies in the short term. That's natural, and because his own body made those antibodies, it's active. He made them. Okay, second situation. This baby has some antibodies because it got it from nursing. There are also some antibodies that go through the placenta. So in this case, this kind of natural passive immunity is a maternal, let's say transfer, not donation, just transfer. Maternal transfer of maternal antibodies. So the baby has some antibodies. They really were made by the mom, and they came to the baby through nursing or through the placenta. That's natural. That could happen without medical intervention, and it does. But it's passive because the baby didn't make those. Okay. I'm next going to go to this one. This girl, this smiley girl, is getting donated antibodies through an IV. Donated antibodies through an IV. Because for some reason she can't make it herself. So. We don't talk about people donating antibodies. Donating plasma, there are some antibodies that they can purify from plasma. I mean, it might be possible, like if it's your family member, for you to donate this. But the point is that some donated, purified antibodies through an IV, this is not going to happen without modern medical care. And she didn't make the antibodies, so it's passive and it's artificial. This one is the best right here. This one is vaccination. When you get vaccines, you are getting antigen. So you get antigen artificially. Which can't make you really sick. It doesn't mean that every person is going to feel like totally awesome all the time after they get vaccinated. It Like if you feel like you kind of are getting sick after you get vaccinated, your body is going through this process because you got antigen and it is ramping up immune response, and you can feel the effects of that. It's feeling kind of bad. It's not the same as completely getting the disease. A lot of people say that they got the flu from the vaccine. They probably have never really had the flu. Probably. So give person antigen separated from the deadliness or the sickness. So when we give people vaccines, let's go back to this. They get the antigen, they do a primary response so that they can get memory cells, and then when they really see the disease, when you really come in contact with flu, you will make antibodies against it. It's not really a vaccine lecture. I could go on and on about that. I wanted to go back to this. Okay. So sometimes what's in the vaccine is whole dead cells. That's a little risky. That's a little bit risky. There are a few vaccines that still work that way. What's more modern is something called a subunit vaccine, where you just get the little antigen off, and that's what you put into people. So just the little piece, just the hanging off piece, just Jake's shoe, not the whole Jake, just the shoe. You need to make antibodies like, I saw this shoe, and I'm so ready for it the next time. I'm so ready. And the next time I see that shoe, I'm going to mount a strong defense against it, along with Jake, who might be wearing it.
Is this because of the sad comment I made? Are you
No, it's just like when I look around the room,
Like,
when I look
what a tag day.
it's because when I look around this room, there is nobody that has like the most distinctive anything that really stands out. Like if it were micro, it would be Justin Williams, and he has that poofy hair. You know who he is? He's got that poofy hair, and then so like if I saw that from far away, I'd be like, that's Justin Williams. But you all don't have any like weird. Your shoes are not weird. They're fine. I just started that thought, and I had to pick something. So I really like.